So in today's video we're going to have a look at water purification. So shortly I'm going to be popping down to the stream to get a sample. So I shall go out and do that. So the intention is to do some chemical tests to see if it has any trace elements. To use a TDS meter, so that's total dissolved solids, to see if there's any particulates in that water and compare it with tap water, and to do a bacteriological test. So we'll stop now. I shall nip out and get the sample, and we'll come back and see what that water contains. There you go. So I'm just collecting some water. It looks pretty clear. I just need to get a bit more. Yeah, I'm going to intentionally do it upstream, try and cut down on sediment. Let's get rid of the leaf. And I'll just try for a bit more without trying to fall in. That'll have to do. So my first test, I'm going to measure the temperature of the water. So I'm going to decant some of the water into this glass. And here I have a TDS meter. So this will measure the amount of particulates, parts per million, in the water. And it will also measure the temperature. So that'll be the first thing. So here we go. I'll remember not to drink this one now, so there we go. So as you can see, the water is really clear. This is from the stream at the bottom of the garden. I'm very lucky to have this. So I've got the temperature set to Celsius. It's reading room temperature at the moment. I'll pop that in there. See if we can get a reading from that. So the water's obviously colder than the surrounding room. So it's going down slowly. Yes, I wouldn't want to go wading in the stream today. It was fairly chilly. So it seems mine is still going down. So we seem to be stuck on 13.7 degrees, so quite chilly temperature. So I'm just going to change the meter over now to parts per million. I just went 13.4, so a bit chilly all the same. So we're just going to shift this and get this in focus. So you can see that's temperature in Celsius. I'll switch that back on again. Then you can have a temperature in Fahrenheit, and then you can have parts per million. So this will show what particulate is in the water. So we'll see how that goes. So I'll just leave that in there for a second. You can see it's recording now. And it's gone straight on to 400 parts per million. Is it going to move at all, or is it happy with that? Yeah, I think it's happy with 400 parts per million. I'm going to test this afterwards with our tap water, which is quite hard. So I did check the temperature again and eventually went down to 13.1. I've now poured a second glass of water from the tap. So the one I'm looking at now is the pond water. the bottle next to it. And then there's a new one which I've just taken out of the tap, and that's 15.6 degrees. I'm colour coding them, so the blue one is the tap water, and then the purpley coloured one is the pond water, so don't drink the wrong one by accident. So the tap water now at 15.8, so I'm just going to change this over to measure parts per million. There we are, so it's gone on to 501. So the weirdly, the tap water has more particulates in it than the stuff from the stream, which I'm quite glad about from the stream water point of view, but you know, I'm just wondering what I've been drinking all these years. I've got some chemical tests which I'm going to perform on the stream water later, and that will check whether it's got any diluted minerals in there, and then a bacterial test as well, which will take 24 to 48 hours to fully come back. Okay, we're back for the second part of the test. I have the 2 glasses of water from earlier. On my left I have the tap water, and on my right I have the water from the stream. The water from the stream actually comes from a natural spring which is about a mile from my house. The stream goes all the way through the village, and I live on the opposite side of the village to the where the spring is, so we may get some runoff and things from people's gardens into the stream, which might cause contamination. You can see, we might be able to see in this light that the samples are slightly different colours. So the tap water is much clearer than the stream water, and if I put my hand underneath, you should be able to see in the bottom there's some sediment which is sort of settled out in the bottom of the glass, which is probably causing a discoloration. If you were going to drink a water from a source like this, you'd obviously filter it first, and that would get rid of the sediment. And if you were concerned about bacterial infections, then you would use some sort of chemical water purifying system. Okay, so the next part of the test is I'm going to use these water test kits. So I have the tube out of the box here. On the one side you can see the different minerals and things it detects, and then there's a colour scale going around, which the darker the colour, generally the higher the concentration of the substance. So that's what we're going to do, and let's find this a second. Okay, so what I was going to say is, in my medical kit I have a similar sort of system for testing urine, and it's works the same way. According to the colour gradient, detects different sorts of substance in urine, such as protein and things, or nitrites, which would indicate an infection. So okay, so I'm just going to pop these out a second. So this kit, I can't remember how much it was now. It was about £20, I think, but I will double check. It's got 125 test strips in, so plenty of chances to test and retest different water sources, and it also came with one bacterial test as well, which we'll do later. So there's the strips. So just pop that down there a second. Close it off to keep them dry. So with these test strips, you're supposed to submerge them in the liquid for 2 seconds. So we'll start off with the tap water. So if I get that all the way in, 1 second, 2 seconds, and then I'm just going to pull that out, just get rid of the excess water. And now if we compare it against the gradient, you'll see the top score. I'll keep it flat so they won't run into each other. So the top straw, you can see it's gone sort of a medium shade of green, and that would indicate the alkalinity was about 120. The next one down, which is the pH, is about 7.2, I think it's about in the middle. The next one is hardness, so it's quite hard. You can see it's all the way over the other side, and that sort of ties in nicely with the parts total dissolved solids that we measured earlier. because it had a high total dissolved solid. Okay, so the next one down is hydrogen sulfate. I'm glad there's none of that in my tap water. And then we've got iron. Again, that's negative, so that's good. Copper, maybe a trace amount of copper. I mean, I suppose that could come from the pipes, but it's somewhere between negative and trace, so I'm not too concerned about that. And the next one down is lead, so no lead, so that's good. So no lead pipes around here. I'm surprised at the age of my house, but there we go. And then the next one down, magnesium, that's also negative. The next two are negative, which is chlorine, total and free chlorine. And obviously if you're going to use this in a swimming pool or something, then you're going to get a chlorine reading. And if you chemically treated it as well, you might detect some chlorine in there as well. Okay, so the next one along is nitrate. So we do have nitrates in there. There's about a third along the 3 out of 5 along the scale of nitrates. Nitrite is negative. The next one is sulfate. So there's trace sulfate in there. No zinc. No salt, and no fluoride, so which that's good. So that's the tap water, so not much in there, which is what we'd expect. And the hardness sort of equates to the readings we got from the total dissolved solids as well. So I'm just going to move the tap water out of the way. And that this is the water from the stream, which comes from a natural spring originally. I'll just pop another test strip out. Pop that there a second. Okay, let's close that off. Okay. So let's not do it. I am cheating actually, because I've got a picture of the bottle next to me because the writing is really small on the test strips and I can't read it very well with this distance from the camera. So, okay, so this is the stream water. So we're just going to dip it in there, make sure all the surfaces are covered. 1 second, 2 seconds. Get the excess moisture off and then try and keep it as flat as I can. So we'll do the same again. So the alkalinity is about the same. The pH is about the same. Again, is hard, so you know that's as it came out before. No hydrogen sulfate, no iron, which is good. Where are we now? Iron, no copper. Let's make sure that's lined up. So that's that one. That 1, 3, 4. No copper. Where we get to? Yeah, no copper, no lead, no magnesium. Okay, I'm just making sure this is lined up properly. Okay, 2, 3, 1, 2, 3. Okay, no lead, no magnesium, no chlorine, which makes sense. Small amount of nitrates, possibly a bit more nitrates than in the tap water. No nitrites. Now down to sulfate. So trace amount of sulfates, no zinc, no salt, and no fluoride. So the spring water as well is got very little mineral content, so yeah, nothing harmful in there. So I hope you found the first 2 tests interesting. I thought it was particularly interesting that the actual tap water had more particulates, was harder than the spring water, which just goes to show, although the spring water had sediment in it, it still was, had less particulates. It was also interesting doing the chemical analysis that both the spring water and the tap water equally had no particular elements in it which could be have long-term health risks. I had intended to do the bacterial test, but after having a look at the instructions, you have to leave it in an area at at least 25 degrees for 48 hours. And as it's winter here now in the UK, I don't think that's going to happen in the near future. So I shall come back to that test and do it again when the weather warms up a little bit. So I hope you've enjoyed the content for this week, and if you would like it, please like the video, subscribe to our channel, and I'll be happy if you leave any comments. I'll be happy to answer them. Thank you. Bye.